me. My name is Ken Jones. I am the manager of our fiber design department here at EPB. And my goal today is really to walk you all through what our day-to-day looks like within the department. I'll share with you some very specific information and details about our department and what we do on a day-to-day basis. Feel free to ask any questions that you would like at any point. If even as I'm going through the presentation, if you have a specific question at that time, feel free to ask that question. I will also have time at the end of the presentation for you to ask questions and also provide just some additional feedback or whatever information. So I am really here for you and to help you with anything that I possibly can. I am also an alum of UTC, so I really enjoy giving back to my alum and talking with upcoming students and future UTC alum as well. So anything I can do to help you all, let me know. Tell you a little bit about my background. My background is primarily in electronics. I had electronics in high school. I got an associate's degree in electrical electronics engineering tech from Chattanooga State. I got a business entrepreneurship degree, bachelor's degree from UTC, and I also obtained my MBA in business analytics from UTC. So that's just a little bit about my background. I've been here at EPB almost 20 years now. So I've seen quite a bit of our growth and our change from the time I came in October of 2000 up into today's time within the organization. I also have included my contact information. So if you think of some other questions or other things that you don't quite want to ask right now, feel free to reach out to me via email or phone call to ask those questions, and I'll be happy to answer anything I possibly can for you. So what I want to do next, and let's hope this video actually plays here within the group, but I am going to play a video. I'm going to play a video for you all that our team collectively put this together along with our HR department helping us out with all the graphics and things like that. So it's a couple of minutes. I'm going to play this first, and it'll kind of tell you a little bit about the foundation of what we're about to get into. And right at this very moment, surrounding you on every side are so many others that dream big like us. And what do we all have in common? We embody a spirit of determination and the daring to be different. We are all leaders. We all have what it takes to create transformational change. That is all about us. This is the story of fiber design connecting to you. Who are we anyway? What is our story?
You hear stories about us always working in GTech and our powerful ambition and our practice as fiber design.
Because we never go backwards. We're always moving forward. Designing this, updating that, to maintain and grow the fiber facility, people base with the growth of Gig City.
Yeah, it takes some audacity, but we have the capacity. We out there, leading the charge. We are job estimators. We are fiber design creators. We are fiber data validators. We are GIS software applicators. We are what it takes to be a change maker.
We have so many ideas. It causes combustion. Some call it fiber construction. Some people ask us, why do we do it? Why do you change things? That's an easy one. Because we are purpose-driven. We have the motivation, the expectation to create innovation.
We don't ask, what can technology do for us? We are technology. 9 out of 10 say I can't, but we say we can if we digitize, we revolutionize, we capitalize.
Well, we know it can change our enterprise. Mobility with GT Web, you mobilize. Your dreams, we visualize. Your connections, we maximize.
We are who we are because we dream big dreams. We look around and we say no to the status quo. Look at that and see there is no substitution for finding revolution. Every obstacle that stands between EPB and our goals is because we have a burning desire to discover and eventually uncover everything out there.
We accelerate as we contemplate that leap we have to make, and we clear it. Can you hear it? It's our celebration. It's our standing ovation.
We are not like the others. We put on the brakes, and they go home, we stay late. We accelerate, we speed ahead, we redefine our very future with the connections we make. I love that video, y'all. Just so y'all know, that video for me was a big team effort with our department, and I'm gonna definitely ask you all questions about that at the end. So, does anybody have any questions before I move on into the next part? No. Thanks, William. So that video was a collective effort of our entire department, and you kind of saw a picture throughout the video of our department and all the people that was actively involved with that, and it was a collective effort. And I think that's one of the key things that makes us so successful is it's not a one-person show, it's a collective effort amongst a lot of people. Not only did that video talk a lot about our department, but it also talked a lot about the company as a whole. And for EPB to be as successful as we are, it takes every one of us within the company working together, coming together for a common goal to be able to achieve so many of the things that we have been able to achieve as an organization. And I want to make sure I mention that to you all, because at some point in the near future, each of you will be in an organization or a company or working somewhere that you are passionate about. And there's going to take times where you have to come together as a team to accomplish a lot of different things. There also will be times where you work as an individual to get your part of the project done or your part of the work done, but collectively together, we are much better as we work together. So I want to make sure that you all understand that is the fundamental concept that helps us at EPB, as amazing as we are and such a great organization to work for. So with that in mind, when you're thinking about your future career and where you go and where you want to be and what you want to do, make sure it's something that you're passionate about, something that you enjoy, something that when you wake up in the morning, you are excited to get up and go. It's not a drag, and it's not I have to go to this location, but it's a place where you really wake up and it's like you go into the playground. And that's how I describe myself when I get up and come to work. I feel like I go to the playground every day and just have a really good time, enjoy my coworkers, enjoy my team members, and just bounce ideas off of them, talk to them about different things, et cetera, et cetera. It really makes a difference in your day-to-day work. So I'll dive in to our department, the fiber design department, and we have 3 major roles within the department. And one of them is our first role that you see here is a data management technician. And we'll go through like some of their day-to-day activities. And part of what they do in our mapping system, which you heard about a little bit in the video, it's called GTech. And GTech stands for G Technology. geographical technology. It's basically our GIS system. And within our GIS system, every house, apartment, business, whatever, we have what's called a premise that we put inside of our GIS system. And we have various premise types. We have a building premise type. We have a suite premise type. We have a duplex premise type. And these are the symbols that are actually in our mapping system itself. And we have house. And we keep going. We have a house meter that could represent either residential or commercial. We have this other that could represent like a billboard or what we call an interrupter, which the interrupters are our smart devices. You may have heard something about EPB smart grid. That's the part of we'll talk about it a little bit later on in the presentation, but we have those premises. We have boat premises for like boat slips. So if any of you own a boat and you get our services, we will actually have a premise that represents your service at your boat slip, whether it's a mobile home. And you can see that you say, well, all these premises look the same. How can you tell the difference? And you're right, they do look the same. They look like a meter center on the stick and a stand. And those are all the same, but inside the attributes, which you'll see a little bit later, there's a what you call a feature explorer box where we have the attributes listed. And that's how we tell the difference between what it actually is and what it actually represents based on the zoning type. We have an apartment, we have a unit and a townhouse. We also have a empty lot premise. So that lets us know that there's no type of house, apartment, or anything else like that, but it is an empty lot that could potentially be developed. And we use those to kind of make sure we are looking out into the future for future development, what can be developed, what might be developed. Does it look like it might just be a single family home? Does it look like it might be an apartment complex? Is this lot big enough to build a subdivision? So we use these symbols to help us as we're looking through our mapping system to realize and understand what potentials might come down the road. So, and this right here is where I was telling you about the attributes. So like if this was a premise right here, you can see the dwell type is other. This is how we would know the difference in that particular premise because of this part right here. It would tell us that this is the other type of dwelling type. So that's where we get all those details for our mapping system. And this particular one, you see this GIS ID. Every premise in our network has a unique GIS ID. So that number is only used one time within our system. And I can tell the address where you see 10 West Martin Luther King Boulevard. And just so happened, this is for our downtown building, our corporate office, this particular premise that we're working with today in our example. As part of that premise, we actually have what's called a service drop that goes to that premise. That's the fiber piece that actually feeds that premise or the fiber that feeds that customer to provide whether it's internet service, phone service, and or video services. So that's the service drop that goes with it. And for that service drop to be able to provide, or that fiber to be able to provide services to our customers, we have to have what's called an ONU and or an ONT. So you might hear ONU or ONT. Those two things are interchangeable. ONU, which is what you actually see on the screen, that stands for optical network unit. If you hear ONT, that stands for optical network terminal. Those two things are the same thing, just depending on who you talk to. Some people may call it a terminal, some people may call it a unit, but they're one and the same. And as you can see, this also has attributes. This tells me the model number. This min code is the model number of this particular ONU. Then you can see the location. So I know this one is located on our mezzanine floor in our IDF room. Also, they have unique serial numbers. So this serial number right here is unique to this particular ONU. So that's some of the data that we capture and we collect and we keep up with within our mapping system that tells us, what we're working on. That's really important when we get into like troubleshooting aspects. So all those attributes of what you just saw, this is a picture of what it looks like on our mezzanine floor. This casing here is just a casing, a housing. This is the O and U, and you can see when I was telling you O and U or O and T, depending on who you're talking to. See, it says O and T here, then back on the attributes it said O and U, interchangeable. That's this box here in the back. This is the service drop piece, which is just what is a fiber jumper plugged into the fiber port. This is our battery backup. And this right here is actually the network switch, where we're actually running our TVs in our lobbies off of this network. So they're all Ethernet based. So that's what you're seeing right here. And this is our TVs in our downtown lobby at our corporate office that's actually running off of this particular unit. Unfortunately, you can't come into our lobby right now because of COVID-19, so you won't be able to see these. But if and when COVID-19 eases up, if you're ever in our lobbies and you see these TVs on the wall, now you know how the services is actually getting to those TVs. Why is this important? So a circuit is built when we actually do a design. This is typically how we actually design the whole entire network to provide services to any customer. There is a premise, which is this part right here we've talked about, the O and U, and again, optical network terminal, optical network unit. Here we have the service drop. From the service drop, we have a multi-port, and what a multi-port is just, it's a part of the fiber that just has multiple ports where you can plug in. In this particular case, this is an 8-port multi-port. So we can service up to 8 O and U's or O and T's off of this particular multi-port. We have various sizes, but just for the one that we picked, this is the one that we picked to talk about. And you can see the 8-port multi-port tail. It goes back to a conventional closure. From there, we have our actual distribution fiber, is what we call it, that feeds that closure, that feeds this all the way out. Here, this is what we call a conventional closure that ties back into the fiber that goes to the actual LCP cabinet. LCP stands for local convergence point. So this is how we actually get fiber connectivity from this point all the way up to that premise. There's a few more details that go in behind the scenes, but for this particular discussion, I've limited it to that much, this part of the discussion right here, okay? So let's say, for instance, somebody calls and say, hey, the TVs are not working. We will actually send a person out to this multi-port point right here, and they would use a fiber testing piece of equipment, and they would do what we call shoot it. So they would plug this up, it would do a reading, and then it would say, at 1,000 feet, I have a break. We would then go into our GTEC system, go into the fiber report part, and as you can see right here, this 1,000 number, and we say 1,000 feet out, where's that point? And then it would give us a report that says, here's all the connectivity, which is basically all that stuff that I just walked you all through a minute ago. This is what the circuit looks like. And then it would place an X at some point where that 1,000 foot is, so we would know where that problem is. At that point, our team says, and let me back up just a little bit. This is our downtown building shape right here. This is the fiber that comes from the inside of the building. So our mapping system is tracing this purplish line out back into the LCP cabinet, and then it goes back to a certain point. So we would then send a person to this location and say, at this structure right here, whatever that structure number is all labeled in our mapping system, is where we believe the damage would be. And so somebody would dispatch, go to that location, somewhere give or take plus or minus a few feet, they will find something of some damage, and then we would start our repair process. So that's pretty much our data management tech side. The engineering side, or the designer side, their work is a little bit different, but their work is exactly part of what we just talked about. But before I go any further there, are there any questions that anybody has up until this point? Okay. All right. So the next one is our designer. We call them designers, but their official title is engineering tech or engineering technician. So we get some subset of work through our CRM system, which is just our customer management system. We get a job and we go in and we find the GIS ID number, which I showed that to you earlier on in the premises, in the attributes table. From there, we actually go copy this information out of the mapping system. In this case, this is a Unum teleworker. From there, we go into our GTEC system and we locate that premise. We have a find feature. We pull that find feature up, put that GIS ID number in. Once we put it in, it tells us that this is your location right here, which is this particular one here. From there, we have to figure out how to get fiber to this location. So we got to find our closest point. So we go in and we say, this piece here is what feeds that location. And then we have to go and find out in our mapping system, do we have an available fiber here? If so, then we use that available fiber. If not, then how do we get additional fiber to that location? In this particular case, put a pin right there. Remember earlier I told you all that was an 8-port multi-port. In this particular case, we're looking at this example, you see this 12 right here. This is a 12-port multi-port. In this particular case, port 12 is vacant. So we will decide to use port 12. So we go in here and we make sure that all the proper connectivity is in place. From that point, we go and we place our ONU and service drop. So this is the ONU, this is the service drop that actually goes back down to that particular multi-port that I just showed you a second ago. And as you can see here, in each one of these steps, we're filling out the attributes for the ONU, we're filling out the attributes for the service drop, we're making sure all those details are put in. And Nate, I will get to your question in just a second. Keep them coming. From here, we have to go in and we have to actually splice that multi-port to that service drop. So we're actually building connectivity at this point because we have some automated systems. And so we're building that connectivity at this point to make sure everything works properly. So now after we place, now we're setting our service available date on that premise. So we go in, we set the service available date, and then now we start to post. The reason we have to post is because when we post, we're telling the GTEC system that all the work for this particular customer to provide them service, it is now ready. Now that it's ready, we say post this so everybody else can see it. And then we have some automated processes behind the scenes where we do imports and exports. So we take and pass this data in GTEC where it's integrated with several of our other systems, and we'll show a little bit about that integration a little bit later on down the road in another section. And from there, all of our internal systems that talk to each other, they know that this particular premise is now ready for service. So we have posted it, and now we can provide service to this location. And then we go, after we've done our posting, we go run a report based on whatever LCP area that is. And that report tells us, I see that premise, everything looks good, it is ready for us to enter an order. We are happy at that point. So at this point, we're extremely excited that that particular customer can now get service. So then we close that activity. We go in, this is just some data where we go in and say, yep, we have completed everything that needs to be completed here. We are ready to go. We close that out. We have what we call a quality control job where we have another employee that double checks behind the work from the previous person. That way, make sure all of our standards, our procedures, and all those things have been followed properly. And this right here is just assigning that to a different team member to do the QC. And then we do AWC, which means all work complete. So here we go in and we close the job. And from here, I don't want to show you that, Jim, sorry. We go in and close the job. And then once we close that particular job, then it is now time for our order entry people to actually enter an order, on that particular premise so that customer can get service. Is there any questions, any more questions up until this point? Anybody? Feel free to ask questions. I will take a second here to pause and answer Nate's question. So Nate's question says, does EPB have a set of core values? The answer to that is yes. A lot of our core values, we have an internal document that we call professional power, where we have some outline values that talk about our customer service, our operational excellence, integrity, accountability, and several things like that that we all live by. EPB is very supportive of our community and what happens. We are an organization that believes that we are here to serve the community. And that's what we try to do every day. You can find EPB sponsoring several events and activities throughout the community as a whole. We actually have a whole internal process about sponsorships and what we sponsor and how we sponsor them. So anybody that wants EPB to sponsor a particular event, they basically submit a request for sponsorship, and based on the exposure and some guidelines that we have internally, EPB may elect to sponsor something or they may elect not to sponsor something. It just really depends. So there's a bunch of criteria that our marketing team handles for that. Stephen asked a question. I'm just curious, are all fiber optics lines transmitted through glass or airbase? The fiber optics that we currently use is all typically some glass that's manufactured that we use. I am not familiar with air-based fiber optics. Typically your air-based stuff is like your microwave, RF, or signals such as that travel, radio signals and things like that. But fiber optics is a physical transmission medium that allows you to transmit light from one point to another point. And then Nate asked another questions. Are the relays PLC driven? So great question. More so on the electric side, I do believe there are some PLCs on our electric side in some of our substations. But a lot of the technology, and this is getting a little bit outside of my very specific expertise, but a lot of the technology inside the substation is becoming more Ethernet driven for automation purposes. It doesn't mean they don't have PLCs attached to them, but a lot of those are really becoming Ethernet driven. So we can actually switch, we can actually do all our switching and everything as needed from a command center or a centralized location without having to roll a truck and do some manual work. I hope I answered your question there, Nate. I'm not quite sure if I completely answered that, but I can table that and get you more information on that. What does the repair process for the fiber line look like? Great question. So typically that process that I kind of walked you all through a little bit earlier, when we get a report of something's not working and we go out and do troubleshooting, depending on the damage that we find, we will figure out what point beyond on either side of that damage do we need to replace our fiber optics cable. Sometimes it can be very short spans, sometimes it can be very long spans. And depending on what's damaged, how far it's damaged, how much it's damaged, what all we find determines what section of the cable we actually replace. So we'll replace X amount of cable, and then once we replace it, we do what's called splicing on each end. So we basically is basically, if you think of welding, it's basically like welding glass together so you can pass light through it. What kind of faults are you seeing most frequently, and how do you repair them? So the most frequent repairs that we have on our fiber optic cable is, believe it or not, it starts with squirrels. They are the worst. They love chewing on the fiber cable, whether it's in the air or down inside a conduit. So we'll see a lot of rodent damage. Especially after a bunch of heavy rains and winds, we'll see trees fall over a lot. We also have people that hit the poles with their vehicles, especially around New Year's, 4th of July, not as much Labor Day, but when you have the fireworks and people not only shooting fireworks, but they also shoot their guns to celebrate whatever it is they celebrate, we get several gunshots. So those are a lot of the things that we have from issues that are most common majority of the time and where the problem lies. Okay, so I got another video for you. This video is, I'll let it play and then I'll kind of talk you through what we're actually doing, what it's actually simulating from our perspective. So what we just simulated there was the start of that video technically starts from one of our substations, and we were simulating building a fiber route from our substation to our downtown building. As you saw, some of that route was outside in what looked like poles and a bunch of stuff on the poles. Some of that was fiber cable on the poles. Some of it was electric conductors on the pole, et cetera, et cetera. And so that's what we consider our overhead piece, or internally for shorthand, you'll hear us say OH for overhead. At some point along that route, you saw where we no longer were overhead and looked like we were going through some tunnel. That simulates the underground piece. So a lot of our facilities downtown are underground in the streets inside of conduits. So that's what that little tunnel visualization was. And then you saw, after you got done with the tunnel, you saw a lid in the ground, which represents a manhole and how you access those particular conduits. And then from there, they kind of simulated going into the building, which is what we were trying to do, simulating coming from our substation overhead, going underground, coming through that manhole into the building, up to our community room on the 7th floor, which is what you see here. And with that, we're going to use our community room as an example of how we build out a fiber network. So I'm going to kind of high level talk you through as we're building out our fiber network. So we talked about the premises. So we have these premises all over the place. As you can see, we're using those tables like they are a lot somewhere, and we have built premises. And from there, this red building that you see is what we call our head end. So this is where everything starts. All of our connectivity, we get our internet uplinks here, we get our video content to this starting at this location, and our phone service starts at this location. And from there, this second red building is what we call a supernode, which is basically just a building where electronics are put into this location. Those electronics all tie back to our head end. So this is our head end, this is our supernode. And from there, we build out a transport fiber ring. And the transport is exactly that. It says, I'm going to transport services from the head end out to the supernodes. And this is red for a reason, because our transport fiber, it all has a red stripe on it. So we know very specifically that that is our transport fiber. So if we ever have any damage to multiple levels of cable, which I'll go into here in just a second, the red stripe cable always goes back first, because that's where your electronics are. So you want to make sure that that always goes back first, so your electronics are built properly. So from here, we have an LCP cabinet, and this blue line is what we call the feeder fiber that comes from the supernode out to the LCP cabinet. This is very important because those electronics inside the supernode, we have a port that we would connect to the feeder fiber that comes to the LCP cabinet, and from that LCP cabinet is where we do our split. It's a 1x32 split to feed individual fibers to all of these premises that you see here. This is where we start to build out our distribution fiber. And let me say this, as you can see, our feeder fiber is blue and our distribution fiber is green. So everything is color coded. So red always gets top priority first, blue gets second priority, and then green gets the third priority. Because this really right here is where everything runs off. All your electronics run off your red, so we want to always get it back first. The blue feeds everything. That's why we call it feeder fiber. So we want to get it back secondly. And then the distribution is what actually goes out to service the customers. So then you start building out a multi-port to be able to serve these customers. You can see here, and then you got your service drops. So that right there is basically how we end up building out. This is how we built our fiber network based on these criteria that I just high level showed you right here. Are there any questions up until this point with this piece right here? Because I know I covered a lot right there. Nope. Okay. So in order to make sure that we can do all of this work, we have what we call our GIS team, or our GIS admins. They are the ones that ensures that all of our systems work well together, that the G technology system that we put all of our fiber mapping stuff in, as well as our electric mapping stuff. I didn't quite cover a lot of the electric stuff because that's a whole nother group that takes care of that. But both our fiber and electric are in the same system. So both the fiber guys can see the electric stuff, the electric guys can see the fiber stuff. So our GIS team, they really ensure that that mapping system works. And this is where our smart grid really comes into play. So you can't have a smart grid without having electric distribution as well as the fiber transmission piece. So it all plays together as one big network, so you can have your smart grid. And that's how you can add your automation into your electric system. You put in certain devices, and those devices talk over the fiber network. Everything comes back here to our control center on the electric side, which is also what we call our head end for the fiber side, okay? So I told you all a little bit earlier that we have several interfaces with our G technology system. And this is part of those interfaces. We have our OMS, which is our outage management system for the power side. We also have an OMS system for our fiber side. Our power plan, which is basically one of our financial management systems that's also tied to GTech. We have our DMS, which is our demand management system. So that's where our electric guys, they look and watch over our load. When TVA says, hey, this is going to be a really heavy capacity day from electric use, let's curtail our load. This is the system that we utilize to try to curtail our load some on peak demand days. We have a system called SIGN, which tracks a lot of our assets that are out in the field. And so our system, GTEC, talks with SIGN to make sure that our systems all match. Our Omnia system is a system that is integrated with GTEC. So that GIS ID that I was telling you about, this is where they go enter the orders so we can place fiber. This is where also it pulls information between the two for billing, et cetera, et cetera. Our GT Viewer system, that's a system to where you can actually be at your desk and have a viewer version of GTEC. You can actually have it on your iPhone, on your Android phone, on an iPad, on a laptop. So it's very mobile. So if you're out in the field and you need to look at our mapping system and see some information or data, or whatever the case may be, you have GT Viewer to look at that data. We also have, this is the GT Viewer iOS piece that I was just talking about. We also have GT Web, which is a web-based platform. And we also have GT Web for iOS. We have GT Plot, which allows us to plot the big maps out of our GTEC system. We have MicroStation, which is where we actually put all of our land base in. So our land base says all of the lots and the street lines and the curbs and all of that stuff is put in MicroStation and it's integrated with our G technology system. So this right here is an example of how our smart grid system works. Let's say, for instance, we have this subset of electric lines and houses or what have you, right? And then there's an electric lightning strike that hits something which damages some device. And then now you have this outage of all of these homes, where our system is smart enough to say all these homes have one thing in common, and that one thing that they have in common is this fuse right here, which is this protection device that looks like an S. That's a fuse. So what our outage management system does, it says, hey, there's a problem on all these houses beyond this protection device. So I'm going to take all of these houses right here and I'm going to roll them all up to this one device, and I want you to send a person out to look at that location. So now we go straight to this device, and typically that fuse would be open, which lets us know, yes, there was a problem. And then from there, the scouters, what we call them, they would go walk this line out and say, oh, right here at this pole, we see something happen and the line is broken, which has caused everything else to be out. So now we know exactly what the problem is, where the problem is, and what we need to do to fix it. Prior to the smart grid system, what we would do is we would just send somebody out to just go ride until they found something. So you can see the time frame with our system telling us a very specific location to go to, minimize all the time it takes to find a problem, and also a time for people to get there to actually repair it, because we know exactly where to go now, exactly where to start, which helps us out a lot. And this right here is our system operating guys. Even with all the wonderful technology that we have in place, as you can see, sometimes they still enjoy using the paper maps. And these two guys here that are in this picture, they have since retired, but there are still times when we need to use paper maps and stuff like that for just different information. At this point, I want to open it up for questions and answers for any and everybody. Any questions?
I guess I will ask, if a student is interested in working at EPB, who would be the best person to contact? And do you guys know if you will be hiring for internships or full-time opportunities for the fall?
So I don't think it's been decided for the fall at this particular point. I do know that there are several discussions going on as far as what hiring an internship looks like. I know that because of COVID-19, all internships and a summer program that we have been canceled for this summer. What the fall looks like, I don't think we know yet. I would anticipate it, and this is just me, but I would anticipate it being very limited, if any, at this point, because we are still in the process of determining what it looks like for our own employees to all come back to work. We have a tentative schedule out right now that's starting to sound like it may even be adjusted, but that tentative schedule brings all of our employees back towards the middle of October, but that may even be adjusted because of all the increase in cases that we're seeing right now. So I don't think there's been any concrete dates and times set aside for internships for this fall.
All right, thank you. I can, of course, follow up with you a little later to see if there's been any updates.
Right, absolutely. The other part is you can always, and even with internships, this will be the place to go. But, if you go to epb.com and then scroll all the way down to the bottom and click on careers, it'll take you to this page here. And then search careers. It'll tell you what positions we have available right here. So you can see there are a couple of positions that are open, a few that are open right now. I do know they have really slowed down on interviewing and things like that. So I don't necessarily know that there's a lot of interviewing going on at this particular time. But I also know that our customer service, which what we call customer service and sales associate, I do know that they are trying to start a new class for that particular one. But that is really in customer service. So I do know that one they are really starting to look and see if they can get enough people in to start a new class for that.
Thank you. It looks like you have a couple more questions in the chat box.
Sure. Oh, which ones did I miss? Oh, I see now. Okay.
Okay. Sorry about that.
Hey, I'm sorry. How many homes and businesses are typically on one multi-port? Great question. So we technically have different sizes on the multi-port. We have a 2 count, 4 count, 6 count, 8 count, and a 12 count. That's all out there in our field. So on those particular multi-ports, those are the counts that can be utilized depending on where those are located will determine what size we put in. There's other things that we do also. If we have larger counts, especially on the inside, we put in what we call a NID, which is a network interface demarcation point. Those come in 12s, 24s, and 48s. So it just really depends on the application and where we use what quote unquote port size. Will this presentation be uploaded? Yes, it is being recorded. And Nicole can tell you more about where she'll put it. It looks like she said the career launch and Canvas page. Once a smart grid has identified a location where the problem is and the operator verifies that a fuse has blown, how long does it typically take for a worker to walk the line and find the point that needs repair? Great question. It's really dependent. And the reason I say it's depending is because depending on how long or how far that particular line is. In the example that I showed you, it was a really condensed version of a line, but some lines can go a very long way. And I'm trying to pull up one now. Let me see if I can find one and share with you all. Like this is the GT viewer system that I was telling you about right here. So if I'm walking, if this tap fuse is blown and I'm only walking this line out, as you can see, that shouldn't take me long at all, because that would be very quick and easy to do. If I start looking at some of these other ones, and this right here, the dotted lines means underground, so I really wouldn't be able to walk much of that out. So let me find some more overhead stuff. And I would get in the area where there's really small. Well, yeah, that's still kind of small as well. But even this one right here, these are a little bit longer than that other one. So, and this right here is what we call back lot. So this is actually like behind houses. So I might have to jump fences, climb fences. I might have to run from a couple of dogs, or you just never know what might happen on a back lot. So it could take you a lot longer to walk this back lot line right here. Even this one right here is kind of street facing here, like roadside. So that one may not take as long. But it really depends on the line itself and what all you run into. See, like this one right here, that's very short. I mean, you could probably stand right here and see to that pole line and know what's happening and going on, so it won't take you, no time. So it's really depending on what that looks like. Other questions? And you all can verbalize your questions too. I actually like talking to people. If you want, I'm cool with that. Anybody got any questions?
So I have one more about the multi-port, if that's cool.
Yeah, ask away.
So it seems to me like there's different levels of multi-ports. Like one is designed for residential use and others are designed for maybe like high power through port for like big businesses and stuff like that. Is that correct? Or
no, so there you can actually use it for business or residential use. And like even if I turn on our fiber distribution mapping system here, I can kind of show a little bit. So this right here is a multi-port, and this is probably all residential here. And we also have what's called a NAP, which is basically a fiber closure where we have service drops that come out of it. So this is an 8-port in the residential area. This looks like a 12-port in a residential area. So it could be residential or commercial. A lot of times, let me see where some commercial, where am I? Let me find some commercial area. Hickory Valley Road. What road is this? And just so you know, this right here is a symbol of our LCP cabinet, sort of in our mapping system. Oh, this is Highway 58. So Highway 58, and where am I? This might be an apartment complex. Let's do this right here, see if we can figure out where we are. I think this right here is commercial in front. Yeah, this is a commercial building here. So you can see in the commercial setting where we're using a multi-port. That's an 8-port multi-port for that commercial building. And these apartments complexes right back here, you can see we're using multi-port for residential. So it could be either or.
okay. Thank you.
You're welcome.
I wanted to follow that up. So could it be that the different kinds of multi-port, it's more based on density and how many areas need service relative to the fiber lines? Would that be more accurate?
Yeah, so you're exactly right. So here's a great example of what you were saying. So in this particular incident, we have a 48 count fiber. You can see that 48 right here. We have a 48 count fiber that comes here and it comes to this point. And then off of that 48 count, because we put these multi-ports in separate places along that building, you have 3 12 count multi-ports. So we're going to be able to service up to 36 customers within that building as a whole. As you can see, we still have, if we had full capacity across all 3 of these and all 36 of these were being used, and I'll give you an example how I can tell what's being used and what's not in just a second. If I needed more, I still have 12 more fibers available. Typically what we do, this particular building probably has about, let's see, 26 off of that. So this particular building has about 30 premises to it. It's 12 off this, 12 off here, and it's 6 off of here. Couple things by looking at this. If you see this yellow or orangish line, depending on what your eyes see, that's what we call proposed. That means that we have a fiber designated for that premise in that particular building, but there's no customer that has ordered service at that location yet. If you see these purple lines, then that means those are active services that are actively have fiber services from us, whether it's internet, phone, or video, or a combination of those. So that's how we can visually look at our system and say how many customers are active just right here. So if I decided to count those, that looks like 12, 14, 15, 16, 17. So 23 out of the 30 customers in this building, we have services to them. Does that make sense?
Yeah, that makes sense.
Did that answer your question also?
Yeah, that was good. Thank you.
Other questions, other thoughts? Give me feedback. What do you think? No? Okay. So I got a question for some of the students. What about this presentation? What is 1 or 2 things that you got out of this presentation that you think can help you?
Definitely understanding how these grids work on a, on a topology scale, I guess.
Okay.
Yeah, I would say, yeah, I've heard about the smart grid before, but I've had no clue how it works or really what it serves. But I think that portion where you went over, finding a fault in an area and using the smart grid and having everything connected so you can know automatically like a point of commonality between, all these areas that don't have service and one point on the lines is really helpful to kind of help me understand the whole smart grid concept.
Okay.
Understanding power load and being able to take into account when things are going to be more taxed versus when they're going to be a little more lax, and then paying attention to where there's overuse and preparing for it. Very, very, very detailed as far as the workings of the company. So very good idea as far as what there is. I would have gone a little bit more detail on the jobs. I know you touched on the engineering technicians, but some of the available ones I would have had a little more use for if there was a way to work that in to touch on a couple of the different degree programs that UTC has to give an idea as to management, human resources, and anything else that's available would have been good too.
When you say that, Nate, you're talking about, are you saying that what jobs EPB has available or what curriculum UTC has that would prepare you for the jobs that EPB has?
I was referring to what EPB has that UTC fits. So, for example, I'm in mechatronics. So I know you went with technology when you went to community college first and then went into more business side. But I know on the website there was a couple of them that were addressed there, where it was the human resources management, but just kind of an idea as to what different options there are through the different programs they had that fit at EPB would be nice to know.
I got you. Okay. So I think there's several different things, and I think that's one of the good things about EPB. Whereas we are an electric organization, electric company, and we are also a communications company. One of the great things about EPB is we actually utilize people from different backgrounds and experiences. And I'll give you an example. Yes, I had electronics experience in my high school years as well as community college. And so I came in with more of a technical understanding and background, which helped me on the communication side, and I get a good understanding on the electric side as well. But we have, in a couple of our roles, like our key customer account role, what those individuals are responsible for is some of our big manufacturing type companies around our service territory, like a McKee or the city of Chattanooga, Hamilton County, various others, right? Those individuals are the primary contact for all those key customers. And we have people from electrical engineering background, mechanical engineering background, industrial engineering backgrounds, etc., that are actually working with our major electric customers. So I said that to say it's not necessarily, oh, you have to, since you're working with our big customers about their electricity, you have to have an electrical engineering degree. EPB is very flexible in understanding that we're really looking for people that are wise enough to be able to learn more than anything. So if you have the aptitude to learn, then you have an opportunity to go into various areas. I'll give you another really good example of that. And this guy has since moved on to other things, which is great for him. But we had a gentleman that worked for us. He was actually an accountant, and he ended up becoming a business analyst for us. He started out as an accountant, but we quickly saw that he had an appetite to go out and find technologies that were good for our organization, do a really good analysis of how that technology fit into our existing business model and or how it improved our existing business model. And so he was moved into a completely different role and started really working in our business development department, coming up with new products, which also helped launch what we call our wholesale division now. So he was able to move around and help start a whole new part of EPB that we didn't see at first. So just small stories like that from EPB's perspective, we just like people that have the aptitude to grow and learn basically anything. Even like myself, I have learned a wide spectrum of the organization and what we do across all pieces. I've worked in our field services department. I've worked with our sales department. I've worked with our meter department. I'm now working in our fiber engineering department. So I've also had a wide range of experiences across several different business segments of our company. So I know that's not very specific, but I just kind of wanted to give you a bigger, broader view of we really just look for people that, one, have that aptitude and that appetite to learn more than just what they know. Does that make sense?
That's very helpful. It's also good to know that there's no stagnation and there's an ability for people to move, whether it be laterally or up. There's always options. And then that kind of led into another question, though. You said you have engineers that are working with McKee in places that require more load. Now, are they tasked out to them, or are they more of like a liaison that just kind of goes there and touches base when there's a need?
it's a little bit of both, right? So the primary part is the liaison. They're really tasked with staying in touch with them on a consistent basis. So they also become like a project manager. So, and I'll use McKee as an example, just because we have a lot going on with them right now, because TDOT is getting ready to widen Appleton Pike. So as part of that widening Appleton Pike, McKee has to relocate some of their facilities. And in relocating some of their facilities, we have their key account rep that works with them as far as what they want to do, what they need to do, how they need to do it, their project timeline, et cetera, et cetera. And that person communicates between our internal departments that handle certain pieces of the puzzle and also with McKee. They also provide them with information and data about, like, if they have different programs, whatever type of programs or incentives that are available, and things like that. So they are a direct contact for the customer, and there's certain things that they can do, and there's certain things, because we have certain departments that do certain parts of it, that they take that information to those departments and say, this is what a McKee needs to do or wants to do. How does that look? Who are you going to assign to work on that project? Other questions? So does anybody have, can somebody tell me, like, what you are looking for yourself, for what direction you're trying to go with your career? Students, you know what direction you're trying to go head to? Anybody?
I'm really into, personally, I'm into networking a lot and network engineering. That's kind of where the field I've been looking into more recently. I worked for a while in high performance computing, and it's kind of strange because I see a lot of similarities in the way networking works with high performance computing, and I'm kind of interested in exploring those similarities.
Okay.
Yeah, for me, I'm a cybersecurity major, so but I've gotten into research recently at UTC. So now I'm thinking about going to grad school and at UTC and trying to stay in the Chattanooga area and finding something to do with relevance to, one, my degree that I'm going to be getting in the spring, and two, in line with my research that I'll be doing as well. So.
Well, I know cybersecurity is hot right now, so you definitely should not have many issues landing a spot in cybersecurity.
I apologize, Ken. I put mine in the comments. So I actually had changed careers. I had gotten a bachelor's in biology. I'm going back to UTC to continue and get a bachelor's of applied science in mechatronics, but with the goal of being a process engineer. And it seems that does get applied there. There's a lot of things where you're trying to fix a problem before it becomes a problem. You're very proactive. I just didn't know if there was any room for that, or a reliability engineer or something to that effect.
Yeah, I think, yeah, Nate, I think absolutely. So I don't necessarily know that we call them a process engineer, but part of, like, internally to EPB, what I would relate to that is more so in our smart grid department, where they are actively looking at what the data is telling us. We collect so much data right now, right, with our smart grid, our smart meters, our smart switches, capacitors, regulators. We're collecting so much data. So part of what those individuals do is they take that data and say, what story is it telling us? And I'll give you a really good example of one thing that came out of that, which was pretty awesome. There was this one customer where early on when we kind of first started all the smart grid stuff, one of the guys noticed a major spike in her voltage. And so we called her or that customer and was like, hey, do you guys have any type of change in your energy consumption? We're seeing some major spikes or what have you. And they're like, no, everything is normal, blah, 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 whatever the case may be. So we're like, well, we got an energy audit team. Do you mind if we send somebody out to do an energy audit? And they're like, no, sure, come on. So we went out, we performed an energy audit. What we found out was that their HVAC system was going bad because their HVAC system was running on the auxiliary heat. And so once we found that out, they actually called the HVAC people out to figure out why. And that's when they determined that their unit was going bad. Well, we caught that early on in the process. So while this customer still had a little bit larger electric bill than what they normally would have, they didn't have months and months of a high electric bill and then find out all of a sudden that their HVAC system went bad. So we were able to proactively go out, work with that customer, help them identify a problem. And yes, they had to get their HVAC system fixed, and I don't know how much that cost them. But, you think about if they found this out 2-3 months later because they had, 2 times the electric bill twice in a month, twice in a row, and then they found out they got to fix their HVAC system, they're a little bit more upset about that. But we were able to help them find the problem early on and reduce their long-term expense. So stuff like that is where, like, from a process perspective, we try to identify those things. And now that we've learned that lesson, we try to implement that as part of our processes to watch out for all of our customers. And that whole philosophy was actually put into the app that we developed for our power customers.
And that's a perfect example. And if you don't call it process engineering, what do you refer to it as? I know it's the preventative and being proactive instead of reactive. I didn't know if there was a title for that job or career there.
Yeah, let me look here. Hold on. I'll kind of tell you what some of those guys' titles are.
And thank you. I'm sorry I'm making this so specific.
No, you're fine. No problem at all. That department, they got various titles like controls engineer, power system consultant, planning engineer, engineering tech. So there's some of the titles that are in that department, and it's really an onus of probably the controls engineer and the planning engineer that really does those. So not quite process, but controls and planning is really what internally we look at and call it. Which they actually have a controls engineer position posted. As you can see,
it's exciting, and thank you for taking the time to do that.
Yeah, no problem. Anybody else?
Thank you so much for taking time to present all of this helpful information. I know even those who weren't able to attend will watch the recording, and they may even reach out to you with some additional questions. So we greatly appreciate your time today.
No problem. I appreciate you all having me. So thank you all, and it's been a pleasure. And if there's any other questions or concerns you have for me, feel free to reach out. I'll be happy to do anything I can to help.
And to students who are still logged in, I will be uploading this to the Canvas page. So if you weren't able to attend the entire presentation or just want to go back and review, you'll be able to do that. And again, Ken, thanks so much, and hopefully we'll be in touch soon.
All right. Thank you, everybody. Take care. Bye.